When it comes to designing buildings and infrastructure, the choice of structural material is crucial. The three most common materials used in construction are steel, reinforced concrete, and timber. Each material has its own unique set of properties, advantages, and disadvantages, which influence their suitability for different types of projects. In this video, we'll explore the key characteristics of steel, concrete, and timber, compare their strengths and weaknesses, and discuss how these factors impact structural design decisions. Let's begin by understanding why material selection matters so much in civil engineering. Steel is renowned for its high strength-to-weight ratio. This means that steel structures can support large loads while remaining relatively lightweight. As a result, steel is an attractive choice for high-rise buildings, long-span bridges, and structures built on soft ground. In seismic zones, where earthquake forces are proportional to the structure's weight, steel's lightness can be a significant advantage. The ability to achieve impressive spans and heights with less material makes steel a favorite among architects and engineers for ambitious projects. Another key advantage of steel is its ductility. Ductility refers to the ability of a material to undergo significant deformation before failure. In practical terms, this means steel structures can absorb energy during events like earthquakes or blasts, providing a safety margin and preventing sudden collapse. Properly designed steel buildings show visible deflections before failure, allowing time for evacuation or repairs. This property is especially important in regions prone to seismic activity, where resilience can save lives and reduce damage. Steel's material properties are highly predictable and consistent. It behaves elastically up to a well-defined stress level, and its characteristics do not change significantly over time. This predictability allows engineers to design with confidence, knowing exactly how steel will perform under various loads. Unlike reinforced concrete, which can change as it ages, steel maintains its strength and elasticity, making it a reliable choice for long-term structural integrity. One of the practical benefits of steel is the speed at which structures can be erected. Prefabricated steel components can be quickly assembled on-site, reducing construction time and leading to faster economic returns. Additionally, steel structures can be built with high-quality workmanship and tight tolerances, ensuring precision and durability. The ease of repair and adaptability for future expansion further enhance steel's appeal in modern construction. Despite its many strengths, steel does have some drawbacks. The initial cost of steel structures can be higher than alternatives, and steel's strength decreases significantly at high temperatures, requiring additional fireproofing. Steel is also susceptible to corrosion when exposed to air and water, necessitating regular maintenance and protective coatings. Furthermore, steel members are often slender, making them more prone to buckling under compression, which can require additional material and design considerations. Reinforced concrete is celebrated for its high compressive strength and versatility. By combining concrete with steel reinforcement, it can also withstand significant tensile stresses. This makes reinforced concrete suitable for a wide range of structures, from foundations and dams to high-rise buildings. Its ability to be molded into almost any shape allows architects to realize creative designs, while its rigidity ensures minimal deflection under load. One of the standout features of reinforced concrete is its durability. Concrete structures are resistant to fire and weather, and they require relatively low maintenance compared to steel. In many applications, reinforced concrete is the most economical choice, especially for foundations and heavy-duty structures. Its long lifespan and minimal upkeep make it a popular option for infrastructure projects where longevity is a priority. However, reinforced concrete is not without its limitations. Its tensile strength is much lower than its compressive strength, and the quality of the final product depends on proper mixing, casting, and curing. The cost of formwork can be significant, especially for complex shapes. For multi-story buildings, reinforced concrete columns are often larger than steel ones, which can reduce usable space. Additionally, shrinkage can lead to cracks and strength loss over time. Timber, or wood, is an organic material with unique thermal, acoustic, and aesthetic properties. It's a popular choice for residential buildings and structures where comfort and appearance are important. Timber is a natural insulator, providing excellent thermal performance. It also absorbs sound, reducing echoes and noise, making it ideal for concert halls and homes. The wide variety of wood types allows for tailored solutions to different engineering needs. Despite being lightweight, timber can have impressive strength, especially when laminated. Its resistance to electrical current makes it a safe material in certain applications, and it doesn't rust like metals. Timber is also easy to repair and maintain, and old wood can often be renewed with special treatments. The diversity of wood species means there's a suitable type for almost every purpose, from lightweight insulation to heavy construction. Timber's main disadvantages stem from its organic nature. It is hygroscopic, meaning it absorbs and loses moisture, which can cause shrinkage and swelling. Timber is also vulnerable to biological deterioration from fungi and insects, as well as abiotic factors like sun and water. Termites, carpenter ants, and marine borers can cause significant damage if not properly managed. While painting and treatments can reduce these risks, timber structures generally have a shorter lifespan than steel or concrete. In comparing steel and concrete, safety and cost are major considerations. Steel can lose strength at high temperatures, requiring fireproofing, while concrete can withstand intense heat without additional treatments. Concrete is generally safer in fire or disaster scenarios, especially when used to encase building cores. In terms of cost, steel structures are often more expensive initially, but their durability can offset this over time. Concrete prices remain stable and are less affected by market fluctuations. Availability of materials can impact project costs and timelines. Steel is often more readily available in major cities, but less so in remote areas, which can increase transportation costs. Concrete and its ingredients are widely available, making it a practical choice for projects in diverse locations. When it comes to construction speed, steel structures can be assembled much faster than reinforced concrete, which requires time for formwork, placement, and curing. Both steel and concrete offer unique design possibilities. Steel's high strength-to-weight ratio allows for long spans and open spaces without intermediate columns, making it ideal for offices and multifamily buildings. Concrete, on the other hand, can be molded into a variety of shapes and can provide more rentable space due to lower floor-to-floor heights. With proper engineering, both materials can achieve impressive architectural results. Steel and timber differ greatly in thermal and acoustic performance. Steel expands significantly with heat, which can cause structural issues, while timber's expansion is minimal, offering better thermal stability. Acoustically, steel reflects sound and may require additional soundproofing, whereas timber naturally absorbs sound, reducing the need for extra materials and lowering costs in buildings where noise control is important. Steel structures are generally more expensive than timber, but they offer greater durability and resistance to natural forces like wind and earthquakes. Steel can last up to 50 years with proper maintenance, while timber structures typically have a lifespan of 15 to 20 years. Timber is more susceptible to deterioration from pests and moisture, but its lower cost and ease of use make it attractive for certain applications. Understanding the types of loads that act on structures is essential for safe design. Loads are generally classified as gravity loads, which act downward due to gravity, and lateral loads, which act horizontally. Gravity loads include dead loads permanent, such as the structure's own weight, and live loads temporary, such as people or furniture. Lateral loads include wind and earthquake forces, which can cause significant horizontal movement and stress in buildings. Dead loads are constant and include the weight of the structure itself and any permanently attached equipment. Live loads, on the other hand, vary in magnitude and location, such as people, furniture, or vehicles. Building codes specify the required live load capacities for different types of spaces, ensuring safety and performance. Properly accounting for both dead and live loads is fundamental in structural design. Lateral loads, such as those from earthquakes and wind, pose unique challenges. Earthquake loads result from ground motion and can cause severe horizontal forces. Wind loads depend on the building's shape, height, and location. Both types of loads require careful consideration in design, especially in regions prone to seismic activity or strong winds. Failure to properly account for lateral loads can lead to catastrophic structural failures. Designing structures to withstand earthquakes involves using special systems like braced frames, moment-resisting frames, diaphragms, and shear walls. Brace frames use diagonal members to resist lateral forces, while moment frames rely on strong joints between beams and columns. Diaphragms transfer forces between vertical elements, and shear walls provide additional resistance. The choice of system depends on the building's use, cost, and architectural requirements. Proper earthquake-resistant design is vital for safety in seismic zones. In summary, the choice between steel, concrete, and timber depends on the specific needs of the project. Steel offers high strength, speed, and ductility, but requires careful fireproofing and maintenance. Concrete is durable, versatile, and cost-effective, but needs proper curing and can be heavy. Timber is natural, insulating, and easy to work with, but is vulnerable to moisture and pests. Understanding the properties, advantages, and limitations of each material, as well as the types of loads a structure will face, is essential for safe and efficient design. The right choice leads to structures that are not only strong and durable, but also economical and sustainable.